All right, so we're going to go through the solution to the practice problem here. So we had set up the first part about how high will it go relative to where it started. Time is the missing variable, so we're going to choose the v squared equation, so vy squared. Again, I'm using this subscript y to indicate vertical translation. If you look on your AP equation sheet, they're all written in terms of x. But again, this is the chosen coordinate system. We're going to keep it vertical. So my initial velocity in the y direction squared, and then plus 2a sub y times change in y position. Now I'm going to plug in my numbers that I know. So I have 28 squared here. My acceleration in the vertical direction is going to be negative, so I'm going to put my negative sign here. 2 times 10, so I've kind of factored that out. And then my change in vertical position is what I want to solve for. So it's my final minus my initial, which is going to be 0. And then my final velocity at the top is going to be equal to 0. Yeah, and I don't think I included that in my, oops, that was probably bad. I should have given that as part of the clue too, but hopefully you kind of figured that out. So plugging all those numbers in and solving for my y position here, I'm going to get 39.2 meters. So hopefully you had some success with that. Okay, calculate the object's velocity as it hits the bottom of the hole. Again, time is my missing variable. I need to solve for that velocity, that final velocity here. So it's kind of a flip of the first equation. I'm still going to use the same v squared equation here. V naught y squared, again, plus 2 acceleration in the y direction times my change in vertical position. V naught y squared is what I want to solve for. My initial y velocity, again, is going to be the 28 meters per second squared. Put my negative sign there, factor it out front, and then it hits the bottom of the hole, means my change in position is going to be minus 10 meters here. So we have that 20 times g and times the minus 10. So my velocity, when it hits the bottom of the hole, when I solve for that square root, is going to be plus or minus 31.4 meters per second. Again, I'm asking for velocity, so I need direction. So I have two possible answers because I know it's going to hit the bottom of the hole moving downward at that instant. My answer would be minus 31.4 meters per second squared. That would be my final answer, or directed down. Okay, calculate the time it'll take the rock to complete the trajectory. Now I need to just solve for time, right? That's my question mark. I know the velocity that it hits the ground from the previous part is going to be minus 31.4, and I know my initial velocity is going to be 28 meters per second up. There are a lot of different possibilities we could use here. We could certainly use the 1/2 AT squared equation. I think it's got a lot more terms in it, but I think that the easiest equation would be using our v equals v naught plus the acceleration times the time. That would probably be, to me, the fewest number of terms. But again, if you chose a different equation, there's lots of different ways to figure it out. So my velocity in the y direction would be minus 31.4. This is why it's important to remember the signs. My initial vertical velocity would be the 28. And then I'm going to put my minus sign in here, 10 meters per second squared, and times my time. And if I solve for that time, if I've done my math right, it should be 5.9 seconds. Okay. All right. Final one. What is the position of the rock at time t equals 3 seconds? Again, I'm going to measure it again because I'm going to measure it relative to my origin, which was at the top of the cliff. So that's what I'm going to measure it relative to. So I'm going to be using my position equation, and I have time. And I know my acceleration in the y direction is going to be minus 10 meters per second. So my missing variable is really velocity, final velocity. I know my initial velocity is still going to be the same, 28 meters per second. Vy is my missing variable, so I don't care about it. So I'm going to choose the equation that doesn't have final velocity in it, and that would be the 1/2 AT squared equation. So I'm going to have y is equal to y naught plus my initial velocity in the vertical direction times time plus 1/2 acceleration in the vertical direction times time squared. I'm going to use that equation. My initial position is 0. And again, if you chose this to be the ground, then if you chose the ground to be your initial position, then you would get this height, final position, would be relative to the ground. So right now I'm setting my initial position to be 0. This is going to be relative to the top of the cliff. So y, I'm going to put in 28 meters per second times 3. Put my negative sign out front there, 10 times the 3 squared. So throwing this all through, this is going to be 84, that's going to be a 45, so I'm going to get a y equal to 39.0 meters, which means it's just short of the top of the cliff. Maybe not the best numbers to pick to make it a little bit different. So hopefully this has taken you through some of the problem. You can see that there's a lot of consistency. I do kind of recommend when you're talking about purely vertical direction to use these subscripts to kind of remind you that it's the vertical directions, especially when we're talking about objects in free fall.